All right, guys, so this is going to be the Algebra 2 semester exam review for Unit 2. So everything that you need to know from Unit 2 will be covered in this review. Well, not everything, but most of the stuff that you'll need. So we'll go over some high leverage skills that I want you guys to practice. So when we're seeing this one here, we know that Unit 2 is all about absolute values and everything that went with absolute values. And so I'm asking you to solve this absolute value. And I want you to graph it and all that interval notation that goes with it. And so when we did these, you want to make sure that we set these up. I'm just going to rewrite it as -7 absolute value of x minus 6 is greater than -56. And so you'll remember, and you want to remember, that we first want to isolate our absolute value. So we need to divide both sides by -7. So then we'll get the absolute value of x minus 6 is greater than -56 over -7 is a +8. Now there was two things that we had to do here. We had to solve both the positive case and the negative case. If you remember, that was what was known as the KISS method. And we'll talk more about the KISS method in more slides to come. But you'll remember that you keep what we have in the absolute value. So if we do the positive case, it's pretty straightforward. You just drop the absolute value and all that good stuff. So we'll do that. And then I'll show you what happens when we apply the KISS method. So let's go ahead and just solve this one here. We'll have x minus 6 is greater than 8. We'll then add 6 to both sides. And we get x is greater than 8 plus 6 is 14. And when we graph that, you're going to go to 14, and you're going to use an open circle, because you'll remember this is not equal to. And we're talking about all the values that are greater than. Now for the KISS method one, when we write out the absolute value of x minus 6 is greater than 8, when we apply that KISS method, remember the K stood for keep. So you keep the absolute value the way it is. So we'll say x minus 6. And then the SS, well, you're going to switch the sign. So now he turns the other way. And you switch this value, so now it becomes -8. And then from here we solve. So then to solve this, you're going to add 6 to both sides. So we'll get x is less than -8 plus 6 is -2. And this is what you would graph. So we come to -2. It'll be an open circle because we're less than, right? Not equal to. And it's all the values that are going that way. So then when we talk about the notations, well, we're going to read this from left to right. So we know we're coming in from -infinity. And we stop at -2. And then we start up at 14. And we go on to infinity. Okay. If you have any questions, let me know. This is going to be your problem. The exact same thing. I'm even going to help you out here, though. I'm going to do one step with you guys first to make this just a little easier before we work this through. So before we work this through, what you guys are going to see is this -3. Yikes, right? Well, to get rid of that, you're going to add 3 to both sides. So you'll have -6, absolute value of 4x minus 10 is less than -87 plus 3 is -84. And from here, I want you to apply the same steps that I did in the last problem. Okay, you'll do this in your Pear Deck. If you have any questions, let me know, but I'll see you in class and we can discuss that further. Let's move on. So this is a word problem 1. It's a similar problem. All that I'm really asking you guys to do is to take the information out and then solve this absolute value. So it says a machine is used to fill each of several bags with 16 ounces of sugar. After the bags are filled, another machine weighs them. If the bag weighs 0.3 ounces more or less than the desired weight, the bag is rejected. Okay, write this equation to find the heaviest and lightest bag the machine will approve. So we want to write this out, and there's some steps here. It says identify your central value and range value. So your central value is like the middle, or where we want to be at. And when we read this question, we're going to see that our central value is here at 16 ounces of sugar, because this is what we want. So we're going to say that our C equals 16. Our range value is how we can either go above or below, plus or minus. Okay, well, like it says here, 0.3 ounces more or less. So it means that our range would be 0.3. So then when we take our equation, we're going to say the absolute value of x minus c is equal to r. Well, when doing this, we just simply plug this in, right? We're going to say the absolute value of x minus 16 is equal to 0.3. And then we solve. Well, for the first case, you just solve it the way it is. You're going to drop the absolute values. You're going to say x minus 16 equals 0.3. We'll add 16 to both sides. We get that x equals 16.3. Well, you want to remember we have to solve for the negative case. And to do that negative case, you need to apply the KISS method. Excuse me. So with that KISS method, we take the absolute value, x minus 16 equals 0.3. We keep the absolute value the way it is. So we're going to say x minus 16. We would switch the equal sign. Well, the switch of an equal sign is still equal. And then we switch this 0.3 to a negative 0.3. And then you solve. So we'll add 16 to both sides. And we'll get x. This simplifies out, equals negative 0.3 plus 16 would be a positive 15.7. So we've already practiced this twice already. I think it's just important to also practice how to take the information out of the word problem to set these absolute value equations up. So now it's your turn. I want you to apply those same skills. You're going to want to identify the range and central values first, set up the equations, and solve for both the positive and negative cases. Okay? If you have any questions, let me know. Let's move on. So on this one here, I'm asking you to solve for your b values, right? Or your x value, or whatever we're asking to solve for. But I'm asking you also to add those solutions up. So just like a little twist here. We already know that those tests always do that kind of stuff. So let's get ready for it. So we're going to set this up as 2 absolute value of b minus 1 plus 2 equals 8. Okay. We first want to isolate our absolute value. So we want to get rid of that minus 2 first, or that plus 2, this guy right here, by subtracting them out. So we'll have 2 absolute value of b minus 1 equals 8 minus 2 is 6. Well, I still don't have my absolute value isolated because I got to get rid of this 2 over here. To do that, I'm going to divide both sides by 2. And I'm going to get the absolute value of b minus 1 equals 6 over 2 is 3. And so this one we can easily solve, right? We know the positive case for this. We just drop the absolute value, so we would say b minus 1 equals 3. We need to add 1 to both sides, and we get that b equals 4. Now I'm not going to box this because this is not our answer. This is a solution. But remember, the question is asking us to solve for the sum of the solutions. So I got to get the other one. So to get the other one, okay, we're going to take the original, this guy here, and we're going to set it up as the absolute value of b minus 1 equals 3. And we're going to apply that KISS method, right? So we keep the absolute value the way it is. We'll say b minus 1. Switch the equal sign, if we could switch it, right? Well, equal sign, switch this to equal sign. But we can switch this 3 to a negative 3. So then when we solve, we'll add 1 to both sides. And we'll get b equals negative 3 plus 1 is negative 2. So our solutions here are 4 and negative 2, and the question is asking us to take the sum. That sum, let me circle that, means that we need to add the solutions. So our first solution was 4. We're going to add that to negative 2. Well, 4 plus a negative 2 is 2. So we just added like one more step. You get your two answers and then you're going to add them together. Not too bad, not too bad. Okay. This question, it's your turn, right? So make sure that you isolate your absolute value. I actually think this one is a little easier than the one that I just did. If you have any questions, please let me know during class or send me a message in Teams. Okay, let's go ahead and move on to the next one. Oh man, everybody's favorite, right? These are like the transformations, and these are a little different than what we've seen in the past. And I want to really go over and like dive deep into what we're seeing here. So it says solve for this location of point P given the following transformations. So I'm looking at this question up here, the one I'm pointing here with the little red arrow. So we're given this point P. And we know that this guy is at -2, 2. Where this -2 is our x, and then we have our y. So we're given this point, and our input, right, is changing here. So if we were to take this, and we look here, we're looking at this g of x equals -4 f of x. Well, what is f of x? Well, we know that f of x is the same thing as y. So what is our y here? Our y is 2. So I'm going to take that 2 and put it in there. We'll add 5. So then that means that g of x, okay, is equal to -8 plus 5. So g of x would be -3. So our final y value, this would be our new y value, okay, is at -3. So this is our changing point. So like we took that point, we multiplied it by a -4, and then we added 5 to it. And this is what we would solve here. And this would be where we get that new point there with a y value of -3. Okay. Now for the point itself, your x, we never changed x. We dealt with all these y's. Your x would still be the same. We'd still be at -2. But then our final point would be at -3 for the y, our x and our y. Because really what's happening is we start off with this -2 here at x. This is what we saw here in the graph. We plugged it in and we got y, or our f of x is 2. But then we took that 2 and plugged it in to solve for g of x. So our initial input of -2 stays the same. Okay, it's just our output that changes. And so I want you to practice that here on this part. If you have questions, which I know you will, please make sure that you ask me, and I'll actually probe you guys on this one, because I know this one's going to be a little different to kind of conceptualize. So this is going to conclude our review for our semester exam for the Unit 2 possible questions that we might be getting. Please make sure that you finish this review, and we'll see you in class. Thank you, guys.